Okay, final lesson of Chapter 8. This is part 2 of our previous lesson, so we're still in 8.6. Remember that we are looking at the law of sines and the law of cosines, which are meant for non-right triangles. So that's the whole purpose of using these guys. All that other stuff that we've done all the chapter long with Pythagorean theorem and SOHCAHTOA and all those things were meant for right triangles. So these are what we use for non-right triangles. These do work for right triangles also. However, it's just not the easiest way to go. When we have right triangles, the other tools that we've been using are much simpler processes. Especially as you look at this formula for today for the law of cosines. We have much easier ways of doing things like this if it's a right triangle. So that's really why we reserve these for non-right triangles, even though they really do work for every triangle. Anyway, here's what we got for the law of cosines. So in our previous lesson in part 1, we looked at the use of the law of sines where we set up a proportion, but it only works if you have one complete ratio. So when we were setting up those ratios, right, we had to know an angle and you had to know the side across from it. You had to have one complete ratio in order to set up your proportion. Otherwise, you don't have enough information. So in a case like this, where I don't have one complete ratio, I couldn't use the law of sines. I would have an equation that I can't solve. And so that's why we turn to the law of cosines. So for this final formula, this is the case where it's a non-right triangle, and you don't have enough information to do the law of sines. Right? I don't have one complete ratio. So this is the only angle I know is this 48 degrees. I don't know the side across from it. Right, which means I do not have a complete ratio of information. So we're going to use the law of cosines. I showed you guys a drawing on the last lesson in part 1 that looks something like this that I wanted to remind you of. So remember what they call the standard drawing of a triangle is where they use the capital letters to represent angles, and they use the lowercase letters to represent the side across from that angle. So capital C would be across from lowercase c. Right, so that's kind of the image that we have to consider when we look at the formulas here. What you're seeing within these formulas, here's kind of the main thing, because it's really all the same formula, but what you need to know about these is this relationship right here. So within this equation, whatever angle I have here, this has to be the side across from that angle. So if this is angle A, then this is side A, which is across from that angle. In this case, B and C are simply the other two sides of the triangle. It doesn't matter which one you call B or which one you call C, right? As long as this relationship is accurate, then these simply represent the other two sides of the triangle. So the same thing would be true over here, right? So if I'm going to work with angle B, then the piece that's isolated on the left needs to be side B. And these would be the other two sides of the triangle. So same thing right here. If I want to work with angle C, then this needs to be the side across from that angle. Okay, and so if we get that relationship right, that's kind of the key to the setup of this formula. So here's what they did with this one. So they were working with, obviously, this angle right here. That was their 48 degrees. So that went in to the equation for the angle. Guys, the rest of these numbers are all side lengths. Right, so once you get the angle figured out right here, the rest is side lengths. So once we have that, so again, this now needs to be the side across from that angle, so that's why they put c squared over there. They then put the 10 and the 12 in for the a's and the b's in all those locations. So that was 12 squared, or at least it should have been 12 squared. I think that extra 2 is supposed to be the exponent, so I think they have a formatting issue. So that should say 12 squared, and this is 10 squared. So those 2's are supposed to be exponents. So anyway, 12 squared, 10 squared, minus 2 times 12 times 10. So we're just plugging in the numbers into the formula, and then we're going to simplify it. So here's kind of a key step in this process. If you look at this equation, you'll notice that on the left side, the guy that we're trying to figure out, it's not just c, it's c squared. So the same way that we got rid of this exponent before is something we still got to do. I have to square root both sides of the equation in order to get c by itself. So that's something we got to make sure that we do in order to get that value. So let's practice. Let's do a little practice on this. So this first one is going to be very similar to the example, and then I'm going to show you a couple different cases here that we can work on. So in case you can't see this very clearly, that's a 14, that is x, that is 12, and that's 62. So when we go to set this up, again, this is the angle that I'm going to be working with. So that makes this the side across from that angle. So I'm just using the formula from up above that looks like this. So a squared equals b squared plus c squared minus 2bc cosine a. All right. So we'll start plugging in some numbers here. So we're going to isolate the x squared. That's going in for a, which makes b and c the other two sides of the triangle. That's the 14 and the 12. And then the one angle, our 62, is going to go in for angle A right there. And this is what we got. So remember, at the end of all this, I have to square root it in order to get x by itself. So the way that I type these in is I just put it all in one shot. There's a lot of information there. I don't want to risk mistakes, so I try to just put it all in at the same time. So I'm going to put it under one big square root. So it looks like this. So I'm just putting in the entire thing all at once. And there's my answer, about 13.5. So that's our missing side length. So I know that formula always looks a little ugly and it's a bit intimidating the first time you see it, but it's nothing more than just plugging in some numbers. And I mean, it's all calculator work, so in one step. So I wanted you to see this one because this one's a little different. It's different because obviously I'm missing an angle instead of a side. What have we always used to find missing angles? We've used an inverse trig function, right? So these ones are tougher because there's a little more work on these if you're missing an angle, but go with me on this. So I'm still using the same formula. Remember the key relationship is right here. So whatever side this is, it's across from this angle. So because I am working with angle B, I want to isolate side B for this piece of the formula here. Okay, so we're going to say 10 squared. And then that makes these two guys simply the other two sides of the triangle, which are 11 and 12. So if I just plug in the information into our formula, it's going to look something like this. Our goal is to get x by itself, right? So we have a little algebra ahead of us. I am going to need to subtract both of those over to the other side. So I'm actually going to write this out so you guys can see everything that I'm doing, so I don't lose you. So I'm going to subtract the 11 squared and the 12 squared. Over to the other side. After the minus sign, this is all multiplication, right? This is negative 2 times 11 times 12 times cosine x. So if I want to get the cosine x by itself, that means I need to divide all this number over to the other side, which you're welcome to just combine these, right? Instead of keeping them separate like I have them right now, but I wanted you to see where everything is going. So I'm dividing the negative 2, 11, 12 over to this side in order to isolate the cosine. So there was kind of the algebra. It's like 2 steps in order to get the cosine function by itself. So I had to subtract both of those, and then I'm going to divide by this number. And so that's what you're seeing on this side. Let me simplify some of that before I start doing trig functions in my calculator, because there's kind of a lot going on there. So let's just get the numerator. So I got 10 squared, obviously 100, minus 11 squared, minus 12 squared. So here's the numerator. On bottom, negative 2 times 11 times 12. Okay, so remember how we did these in our previous lesson, that if I'm solving for an angle, the only way to get x by itself is with an inverse trig function. So I'm going to do the inverse cosine of my ratio, which is 165 over 264. And I'll just turn those into a plus because it's like that double negative, right? Negative over a negative is positive. So that's how we can get x by itself. Let's type that in from there. And there's our missing angle, about 51.3 degrees. Good stuff. Okay. So those are kind of the 2 different versions that you can run into. Really not much more to it than that. Here's a case where they're asking us to solve the triangle. So we dealt with this in section 8.4, where we had to solve the triangle. Remember, that just means find everything that's missing. So in this case, I have to find the 3 missing angles. 3 missing angles. Because it's not a right triangle, I'm pretty limited on what I can do here, right? So I can only use law of sines and cosines. Now if I look at this, I don't know any of the angles, so I definitely don't have a complete ratio anywhere, right? Which means I'm going to have to use the law of cosines to find something. So just pick one to start with. So I'm just going to pick angle A. Okay, so if angle A is the angle I want to find first, well, across from him is the 7. So that's that relationship that we talked about right here. So if this is angle A that I want to find first, then I want to have the 7 right here. And so the B and the C are simply the other 2 sides of that formula. So I'm going to say, I'm going to have to write a little small here so I have enough room. In fact, let me do this so we don't get confused on what's what. All right, so there's our setup to find angle A. Remember what we did on the last one? Remember, if you're missing an angle, you're going to need an inverse cosine in order to find it. Okay, so that's how we always find our missing angles with our trig functions. So I'll take a little bit of a different approach on this one. Maybe this is easier. I wanted you to see where everything is going on that previous problem, but now that you've seen that, maybe here's an approach that you could work through in case this was kind of tough. What if we just simplify it a little bit first? So 7 squared equals, let's see, what is 64 plus 100? And then right here I have 2 times 8 times 10, so 16 times 10 would be 160. So now you can see the subtraction. I have to subtract the 164. And then I'll divide by my negative 160. to isolate the cosine. So what do we got here? So if I did 49 minus 164, my numerator is negative 115. My denominator is still 160. So let's do the inverse cosine of 115 over 160. So our angle is about 44 degrees. So we just figured out this guy's 44 degrees. So here's something I want you to notice, is I now have one complete ratio. So if I now wanted to turn to the law of sines to find another missing angle, I could. However, one of the things that we don't really get into at this level is there's kind of some weird exceptions depending on these numbers that sort of keep you from using the law of sines correctly in a case like this. Instead of going into super depth on all of that, let me just tell you what they would tell you is the safe approach. The safe approach is, if you're finding a missing angle, to use the law of cosines every time. So that's going to be their advice, so I'm going to stick with that for now. So whenever we're missing an angle in a non-right triangle, I'm going to use the law of cosines. So let's just say we wanted to go after angle B as my next one. So if I'm going to use angle B, again, the 10 is across from that. So I'm going to isolate the 10. Seven and 8 can be the other two sides. So there's our setup. Exact same math, so if you want to practice this, then I definitely encourage you to do it. Let me set it up and solve it so you can check your answer. So we should get about 83.3 degrees if you do that correctly. Remember, when they say solve the triangle, they do want you to find everything that's missing. So in this case, I got one more angle to find, but once you know two of the angles, all I got to do is subtract them from 180 to get my third one. So our third missing angle would be 52.7 degrees. All right, guys, that is it for Chapter 8. So as you're going through this homework today, of course, you definitely need to be showing work like this. And, you know, as always, if you're struggling on any of these, let me know during class and we will do some together. But that is it for Chapter 8.